So today we're going to be solving absolute value equations. So the biggest thing to remember is whenever we put anything in absolute value, it becomes positive, right? So if I get this equation and I'm trying to solve for y, then y can either equal 8, which is like the easy answer, and then y can also equal negative 8. Because anything negative, once you put those absolute value like brackets around it, it becomes positive. So on the flip side, this is saying I put some random thing p in the absolute value brackets and it's negative 6. This isn't allowed. This is not possible because this has to make it positive. So it's just not possible. So the tricky thing happens is when you have to solve an equation. So pretty much what you want to do is one of the versions, the easy version, you could just pretend the absolute value isn't even there. So that's one solution, and then the other solution, it would equal negative 5. Because if I put this chunk in those brackets and it was negative 5, then the absolute value sign would turn it back into positive 5. So these are our two equations right here, and then we can just solve like we have been solving. So we add 3 to both sides, 2x equals 8, we have x equals 4, and then here we add 3, and then we have 2x equals negative 2, which means that x equals negative 1. A little bit of lag. Okay, so this is how you solve absolute value equations, but let's write it down in steps so that it's a little more organized. Okay, so the first step is you're going to move everything outside the absolute value bars to the other side. So if we look at this example right here, they want us to move everything outside of the absolute value to the other side. So first we're going to move that 3, 12, and then we're going to move that 2. So we have to divide everything by 2. So we have absolute value x minus 8 equals 6. So this was the first step for this problem. We got everything away from those absolute value bars to the other side in like reverse order of operations, right? So normally we do addition and subtraction last. That's the first thing we do when we're moving it to the other side. All right, the next step is set whatever is inside the absolute value bars equal to the number and its opposite. So that's a lot of words, but essentially we're just taking what we got from step 1 and we're setting it to the number and then we're setting it to the opposite. So we're doing x minus 8 equals 6 and x minus 8 equals negative 6. And then finally, we solve both equations. So this is normal. This is like your normal like 1-step, 2-step, multi-step equations, which is like lesson, like unit 3 or something like that. It's like a while ago. The tricky thing is now we just have these absolute value bars. So for step 3, we're going to add 8 to both sides. So we're left with x equals 14. And then here we also add 8 to both sides. And we have x equals 2. So we can check it, and there is absolute value in the calculator. So I'm going to show you. Okay, so if you go to math, number, abs, that's absolute value. So I'm going to write it here. Math to number, and then it's 1 abs. So that stands for absolute value. It's calculator. And once you push that, it'll make the bars for you. So if I wanted to check my answer, which I always recommend you do. Okay. So we go, let's try 14 first. So we have 2 math number abs, 14 minus 8 plus 3. And we can see that it equals 15, right? So this is me checking my answer, which you should always do. See if I can do a different color. Right? Check. And then we could do it again. We could do 2 math number absolute value, 2 minus 8, because now we're checking the 2, plus 3. That also equals 15. So we know that we got it right. So you always want to use your calculator to check, because you can turn in a test and you can know if you get it right. It's not like some mystery. You can always check with math, which is like the fun part. Okay, so let's do a few examples. Okay, so my first step is I'm going to move everything to the other side. So I'm going to add 8 to both sides. So I'm left with absolute value of x plus 5 equals 23. My second step, I'm going to set one of them equal to like how it is normally, and then the other one is the opposite. And we minus 5 from both sides, we get x equals 18. And here we also minus 5, and we get x equals negative 28. So something that sorry, that was the beginning. So if we like have our GEMDAS, right? If we look at this equation right here, we have a parentheses, which is a grouping, and we have a subtraction, right? Those are the two operations we have. So when we're trying to solve, we do like the reverse, right? So the first thing we did was the opposite of subtraction, which was addition, and then we dealt with the grouping symbol. So whenever you're trying to solve for something, you like do GEMDAS in reverse. So like, let me show you another example for it to make more sense. So if we look at this problem, we have a grouping symbol. This absolute value is grouping. We have a multiplication right here because we're doing 2 times. And then we have an addition right here. So we have a grouping, a multiplication, and an addition. So when we're trying to solve for this, we're going to go backwards. So we're going to deal with the addition first by doing the opposite. So we're going to minus 4 on both sides. We're left with 2 absolute value, 3x equals 24. And then we deal with the multiplication next. So we're doing the opposite of multiplication. We're going to divide 2 on both sides. And we have absolute value 3x equals 12. And now we can finally deal with the grouping symbol, which is like what our 3 steps were up here. So this is our first step. Our second step, we have 3x equals 12 and 3x equals negative 12. And then hopefully you could do this in your head. We have x equals 4 and x equals negative 4. And again, you could check that in your calculator, which I would recommend. Right, so we have back at the original. So when you check it, you always want to go back to the original problem. So we have 4 plus 2 absolute value 3 times 4. That equals 28. And then we have, we're going to do negative 4. And we still get 28. So we know we did it correctly. All right, so take this one's fractions. Okay, we'll do this one together. Okay, so this one is fractions. It's not that bad. It's the same thing. So we have a grouping symbol. We have a multiplication we have a subtraction. So we're going to go opposite. We're going to add 8 to both sides. Then we're going to divide by -5. And this one is actually nice because remember, anything that's an absolute value has to be positive. So the fact that this ends with a negative, we just say no solution. We didn't even have to deal with the fraction. All right. Can't have something in absolute value bars be less than 0 or be negative. Right. Okay, at the start of the beach volleyball season, Miss Letts has to make sure that all the volleyballs are inflated correctly. They must be 9 pounds per square inch, PSI, with an error of 0.5 PSI. So what is the maximum and minimum possible PSI for all of the basketballs? So you might even be able to figure this out just like thinking logically. Like an error means it could be 0.5 on either way. So you don't even have to use absolute value to solve it. Like in your head you could probably think, okay, it's going to be 8.5 to 9.5. But to do it with absolute value, just so you can like work backward and use it for other word problems, is you can write it with an absolute value, x minus 9 equals 0.5. So this is saying like our ball inflation minus 9, the absolute value of that, so like on both ends it needs to equal 0.5. It needs to be like less than or equal to 0.5. Well, I'll just keep it equal. And so then you could set this up doing our normal steps. So we have x minus 9 equals 0.5, x minus 9 equals negative 0.5, and then we solve. So we get x equals 9.5, x equals 8.5, and that's how we get our range. So this is sort of seeing one in context with like a word problem, but with some common sense, you might be able to answer it anyway. So whatever you feel more comfortable with. All right, so we're gonna try these on our own. So pause the video and then come back. Okay, so for this one, we have our GEMDAS, right? Just to keep track, this one, we just have a grouping symbol, that's all. So we don't have to do any special, like step one is already completed. Already done, right? If we were to go back and look on the back side. Okay, so the second step is 3x minus 1 equals 13 and 3x minus 1 equals negative 13. We add 1 for both of these. We get 3x equals 14, 3x equals negative 12. So we get x equals 14 over 3 and x equals negative 4. And then for the next one, we have a grouping symbol, we have a multiplication, and we have a subtraction. So we're going to do everything in reverse. So we're going to start with the subtraction. We're going to add 3 to both sides. Equals negative 12. Then we're going to deal with this multiplication. So we have to do the opposite. We're going to divide by negative 5. So we get absolute value of x plus 3 equals a negative divided by a negative is a positive, so just 12 over 5. So now that we've gotten this absolute value bars by itself, we can move on to step 2. We set it equal to the positive version and the negative version. And then we solve. So minus 3. I'm going to rewrite, okay, let's do this fraction. 12 minus 5 minus 3, or 12 over 5 minus 3 is the same thing as 12 over 5 minus 15 over 5. So that gives us x equals negative 3 over 5. And then here we have x minus 3 on both sides equals negative 12 over 5 minus 15 over 5 again. This becomes x is negative 27 over 5. It's a little bit of fractions, but you can also use your calculator. And so this is it. This is pretty much just solving for x, but you got to be careful with the absolute value. So for example, someone asked if like we distribute, and normally you would, right? If this was a normal parentheses, you would distribute. But since it's not, we have to get it by itself so that we can go to step 2. Right? Okay, so that's it.